In chapter 4, we're going to start taking a look at the idea of the application of the derivative. In chapter 3, we took a look at all the different techniques of being able to find the derivative. So now what we're going to do is, what is the derivative good for in this section? And this is one of the most important things that we're going to get out of this Calculus 1 course is utilizing the derivative for optimization. And before we can start any sort of applied problems, we have to start with the idea of being able to look at graphs and apply the derivative. And so in sections 4.1, 4.2, and 4.3, we're going to do exactly that. And we're going to start with just a basic idea of being able to find maximum and minimum values of functions. And so if you look at the graph, let's just call this a function f. And notice that f is continuous, meaning that, and you might remember from chapter 2, continuity basically means the domain of the function. And let's say this is some point A, and this is some point B right here. And what we can say is f is continuous on the interval AB. And we notice that there are some maximum values. And we have different types of maximums and we have different types of minimum values. So we have these things called local maximums. So it's basically going to be a high point or a low point, maximum, high point, minimum, low point. But it's not the highest point on the function, but it's one of those points of inflection. All right, so right here, where I'm drawing this dot, would be a local maximum, but it's not the highest point on the function. In fact, A would be the highest point. And same thing with a minimum. So right here, this would be a local minimum as well. But we have these things called global or sometimes absolute. Okay, so for our purposes, if you ever hear the term global and absolute, those are the same things, right? So global maximum is basically going to be the absolute highest point of the function in the given interval, or the absolute maximum. And the same thing with the minimum. And one of the first tasks that we're going to be charged with is, if you're given a graph, to be able to just inspect, to be able to identify local as well as absolute maximums and minimums. So let's take a look at those examples first. And here's another graph just to kind of give you an idea of what we're looking at. So again, we have an interval that ranges from A to E on a continuous function. So let's call this function G. Notice G is continuous on the interval from A to E, where A and E are points on the function. And we have these relative maximums, and then we have absolute maximums. Okay, so right here we have our relative, and we have a relative as well as an absolute. So a maximum could be both an absolute and a relative. All right. So we have to be cognizant of that fact if it's within the interval. It doesn't necessarily have to have an absolute maximum in the interval. It could be at the endpoints. All right. So, but the relative minimum is always within the bounds between, in this case, A and E. All right. So let's take a look at a couple examples. And if you're given the graph, let's make sure that we can identify what the local max, local min, absolute max, and absolute mins are. All right. So we have this function. Let's just call it f, and it doesn't really matter what we call it. And we notice that there's a number of points, A, P, Q, R, S, B. And if we want to identify the local minima in this interval, well, it's pretty easy. So a low point would be Q, and we notice that Q is one of the lower points that occurs. Right? And then the function, we just trace it, and then it has a high point at R, and then it has a low point at S. All right. Now those are local, meaning that they're in between the interval. So our local minima are going to be at points Q and also at point S. And the local minimum, I'm sorry, these are the local minima, excuse me. But the local maxima are going to be at point P. So notice that the function goes up, 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 and it kind of reaches a maximum, and then it starts going down again. And another local maximum is at R. So we have P comma R. But those aren't necessarily the absolute. Okay, and absolutes are going to be at the points to where we have the highest and lowest values. Now, the highest point, obviously, is going to be B. It's the very highest point in the function. And the very lowest point on the function is A. Right? So notice local means in between the endpoints. All right, so local, we're just looking at in between. And since none of the points P, Q, R, S are the highest or lowest points, they're local, but they're not absolutes. All right, so hopefully that makes sense to you. A second example of this, we want to just use our graph to be able to identify the points where we have absolute extreme values again. So we're going to trace our function, and let's just look for the maxima first. And so we notice that R is a high point. Okay, it's a local. We're not going to worry about A because it's the beginning of the interval. So neither of these can be locals. Okay, just like up here, neither A nor B are not locals as well. Okay, so endpoints are never local minima nor maxima. Right? So in this case, the only local maxima in this problem is going to be R. It's the highest possible point. There's two local minima, as you probably already deduced by looking at the graph. And we have one at Q. And unfortunately, S, excuse me, it's not 2. Notice that S is not really a minimum at all. Okay, it kind of just, it keeps going down and down and down. And it's not really necessarily going to be a minimum. All right. Because on the interval from R to B, it's not really a point of inflection. All right, so it never really kind of turns down. It just keeps going down from R to B. So we can't necessarily say that S is going to be a minimum. So we're going to say that Q is a local minimum. And of course, the absolute highest point of the function is A, and the absolute lowest function or point of the function is B. Okay. Another concept that we're going to look at is how do we do this algebraically or analytically? And so that's what we're going to look at in the next video is how do we go through and try to find the maximum minimum values if we're just given the function, but not the graph of that function.